Hey guys, welcome to Breaking Code. So in this series, we will be solving top interview 150 questions. So the first question is merge sorted array. Okay, let's start the question. So the question states you are given two integer array nums and nums2 sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2. Merge nums1 and nums2 into a single array sorted in non-decreasing order. So we can use directly the merge sort algorithm, uh, where you keep left and right at the starting point of the two nums, and you can sort according to the ascending order. So before coding the question, I would like to do a dry run before that. For that, we'll be using good notes. We will take our own example. So we are having like 1, 2, 3, and 4, and we are having an array n1 and n2. So in n2 we are having variables like 2, 3, 4 and 5. So you need to create, like you need to merge into the first array in a ascending order. 2, 2, 3, 3, 4, 4 and 5. So this is our output, and you need not to do extra array where we are having the space here. As in the question, it shows that it is having extra zeros which are need to be put in the n1. So for that, what we are going to use, we'll be taking 2 points. We'll consider this as left and we'll consider this as right. For now, what we'll be taking is, we will take an array, separate array, and we'll be keeping one variable which is having less than. So if you check here, left and right. For example, left is having at 1 and right is having 2. We need to satisfy this condition where left is less than or equal to right. Then you need to put them in the array. Else you need to put the right element in the array. So we'll be putting the first element and we will be moving the left pointer. So now check the condition. If you check here, left is less than or equal to right. If it is in that case, you can add that variable here. Sorry. You can add the variable in the array and move the left pointer. Now we are moving the left pointer. So if you check now, the left is 3, left is 3 and right is 2. So this condition fails. So we need to put the right pointer in value in the array. So you have put this. Now increment the right pointer. Now check which condition satisfies. Left is having 3 and right is also having 3. The first condition satisfies. Now put the left index value in the array and move the left pointer. Now left is 4, right is 3. Here the first condition fails and we need to put in the array. Now increment the right pointer. So here right pointer value is 4, left pointer value is 4. So the first condition satisfies. Then we are putting the left pointer value in the array and moving the left pointer to next. So if you check, what we can write the base condition is while left is less than or equal to m and right is less than or equal to n. So once we have completed and the left pointer moves to the end of the array, so we'll be breaking this loop and we'll be checking separately whether any of the variable, like for example if the left pointer is less than or equal to m, what we are going to do, we are going to put the left pointer values in it and increment the left pointer. The same goes for the right pointer as well. So I'll be writing the further. Next, y then are equal to n array of right and right plus plus, and at the end we need to return the array here. So the code checks here whether left is less than or equal to m. Then it goes to the while right is less than or equal to n. Yes. Then we are putting the 4. Then we are incrementing the right. Right will be moving here. Then putting the right, and right will be moving plus plus, and right is greater than, sorry, it is equal to n, so it breaks and return an array. So we got the array that is 1, 2, 2, 3, 3, 4, 4 and 5. So I'll write the code for it. We'll be taking a new array plus n. And plus n minus 1 will be taken because you know that it will be having 0 index base. So we'll be placing the left pointer at 0 and the right pointer as well. While into n and n. We'll be checking the first condition that if nums1 of left is less than or equal to nums2 of right, then we are going to add. So we'll be taking one pointer where it increments everywhere. We took the k variable, array of k plus 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 equal to nums1 of left, then else array of k plus plus equal to nums2 of like if not then while equal to I think I should prove here that is less than n. Array of k plus plus equal to nums1 of left and nums4 left plus plus as well. And array of plus plus and we can directly return the array. I think it's fine. Oh, so what we can do is I made a mistake using the array and I'm taking the size of n plus n minus 1. That's why we got array index out of one exception. So I replaced with array list. We can do with array as well, but uh, let's go to the next question. I think we're having one more approach where we should not use the list of integer as well, because here if you check the time complexity, time complexity will be somewhere around. So we are learning O of m plus n, and we are using another array to copy. That will be size of m plus n. You can say the time complexity will be of, and the space complexity will be O of n. So we need to reduce this space complexity. So for that, we can come up with another approach. I'll be explaining that the approach now. So if you check here, we know that the array size will be m plus n, because the size of this array is n and the size of this array is n. So these array also contain the size of n as well, which contains 1, 2, 3, 4, and 0, 0, 0, 0, and 0. So we need to place these items here, and you need to sort the without using an extra space complexity, that is array list. So we can come with a different approach. I will try using a different approach to solve within the time complexity of O of m plus n and the space complexity with O of 1. So for this, what I can do is, uh, I can place a j variable here and a I variable here. We know that largest numbers will always be at the end of the array, as it was sorted in ascending order. So we know that the largest elements will always be at the end of the array. So we only need to put the array where here. So for example, if we take that, we will be putting the elements from the end of the array. So if you check here, we can put 5, and we can put 4, then you can put 4, then you can put 3. So after putting here, what you can do is 3, 2, 2, and 1 as well. So with this, our time complex will be O of m plus n, and the space complex will be O of 1. For this, put the j variable, the m and j variable at the end. 5, 4, 3, 4, 3, 1. 1, 2, 3 and 2, 5, 6. Two, 5 and 6. Already having 1, 2, 3 and 0 and 0 and 0. So we'll be checking which is the largest element among these two. So we know that 6 is the largest element, and we will be decrementing this. And we know that next 5 is a greater element, then we'll be taking that and decrement it. We check here, 3 is the largest number. We'll take that and decrement. Then 2 is the largest. We'll take it from N1 and we will decrement. And 2, we'll be putting 2 here and we will decrement this as well. And it goes to the end, and we need not to sort the first term because it is already sorted. And take int I equal to n minus 1, int j equal to n minus 1, n plus n minus 1 equal to 0. So I will be starting from length minus 1. I will be this if once 1 of I is greater than once 2 of j, then what we're going to do is once 1 of I is equal to, I'll take a here. I is greater than once 2 of j, then once 1 of k is equal to once 1 of I, and minus minus. is equal to nums to j, j minus minus. If this is done, so can return nums one. But I think I need to handle some more edge cases, I guess. Here we also need to check the condition that it should not be greater than it should be greater than or equal to 0. So if you check here, 1 and n2 is nothing, like it's an empty array. The length is 1 here, the length is 0 here. We check n plus n, that is 1, and we are running a loop that is length minus 1 and it is greater than or equal to 0, then this one is condition satisfies. But when you come here, if nums of I, you check the nums of I, here it is 0, it is greater than nums of j. But if you check j here, we initialize I equal to n minus 1 and j is equal to n minus 1. So if you, here it 0, 0 minus 1, so j is becoming minus 1. So for that we need to keep a check that the j should not be 0. For that I can directly keep think I can take k as n plus n minus 1. Instead of traversing with this, what you can do is keep like while j is greater than or equal to 0. If I is greater than or equal to 0, and once one of I is greater than nums to of j, then we can once one of s is equal to nums one of a. Else nums one of is equal to nums 2 of j minus minus. And don't need to return anything here. Yeah, if you check now, the time complexity is O of n plus n, and the space complexity is O of 1. Yeah. Oh, you have directly taken by here, so that, yeah, that's it. We'll be moving to the next question. I have already solved these questions, but for time being, I'm starting from the start point. Okay, here we need to remove the value 3, and we also need to not dismantle the sequence of the array. So here if you check, the nums is 3, 2, 2, 3, and value is 3. Here we should remove 3, and we should place in place of 3, like it just like a swap between 3 and 2, and we can move this 3 to the end of the array. And your function should return k equal to 2 with the first two elements of nums being 2. It does not matter what you have. Okay, so it doesn't matter what we leave at the end. So we can just move all those things, all those values to the end of the array, and we can keep the first elements by removing the value. Okay. Here, if you take the time complexity, nums dot length is always greater than or equal to 0 and less than or equal to 100, and nums of I will be less than or equal to 50, and value is less than or equal to 100. Okay, that's fine. So to solve this question, we are having 3, 2, 2, and 3. So you can simply do the thing we can do is we'll be keeping a variable I, and a loop runs from j to 0 and j less than n and j plus plus. So instead of taking this I as well, what you can do is, if nums of j is double equal to the value, then we can swap nums of j with nums of j plus 1, then you can take a count variable or else I something. So whenever there is a swap done, so you can increment that count as well. So if you check here, no, instead of count, we can take the pointer I equal to 0. So whenever the swap is happened, I will be at the point of the swap number, that is j. Here if you check, we'll keep I as 0, j is also 0. So here nums of j is value, that is 3 double equal to 3. So there is a swap, so it goes here and this goes here. So it becomes 2 comma 3 comma 2 comma and 3, and I will be j pointer here. So j will be here. Now once again we got this variable. Now swap, it becomes 2 comma 2 comma 3 comma 3. So j. What we can do is, instead of checking for the value, we can check if I'll give another approach which is clear. Three, two, two, and 3. I'll be taking the pointer. So whenever j finds, I will be putting that I equal to 0. So then j plus plus. Whenever j finds the value, we will swap with the nums of I, nums of j, and I will be plus plus. example, we'll be taking 3, 2, 2, and 3. We'll be taking a variable I is equal to 0 and j will be moving. J less than and j plus plus. Here n is nothing but length of the array. So what we can do is, if j is not equal to value, what we can do is nums of I equal to nums of j, and we can increment this I plus plus as well, and we can return this I as well, because check here, we are starting with I and there is a variable with value 3 which is equal, so we will just move next. So here, okay, we are checking for value 3 here. When we got 2, what we can do is, I is standing here, so we can directly make 2 here and it will be 3, and I will be standing here. Then once again you get 2. What you can do is 2 and nums of I equal to nums of j, that is 2, and here there will be 2 and here there will be 3. Here once again you will get 3, so we can leave. So after the elements left over, we should, like, we need not to care like what are the elements left over here. We just need to know that we are returning the number of values after removing the value. You can say like count of after removing the value. So you can solve this easily as well. Give me a second. We're taking index equal to 0, I less than start 10, then I plus plus. If nums of I is not equal to, well, we can directly put nums of I equal to nums of index is equal to nums of I. You can do index plus plus. I'll be writing index one line instead of making it 2D. X plus plus, and you can return the index. You can also use the brute force approach. So, but I have written the optimal approach. So you can directly use the brute force or take a new array with size same, and you can directly put the values 2 and the leftover values you can keep 3 or something, because they won't care like what are the leftover values. You check which guys are being fast. Okay, we'll go to the next question as well. So, like, we should remove the duplicate in a sorted array. So this also like we can use the similar approach which where we have solved the above question as well. So it is, so here also it doesn't matter what you have leave beyond the return key. So the brute force approach will be like you can take a hash map and find the frequency, and you can take one element and you can directly put the key elements which are present in the hash map, and you can return the value. That is also fine. So we'll be using directly the optimal approach because it's an easy question. I don't want to waste. Already it's like 53 minutes for two questions. I think it's too much. You have to with the first two elements. Okay. This we can do is 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. The test case they have given is like 0, comma 0, comma 1, comma 1, 2, comma 2, 3, 3, comma 4. So we will be taking an index which stands at I, and a loop from j to n as well. So what we are going to do is whenever if j is double equal to nums of I, if j is not equal to nums of I, we can so j will be starting from 1 because we know that the first element will always be the unique element. So when you are placing at I, you need to check if nums of j not equal to nums of I. Then what you're gonna do is nums of I equal to nums of j, and you can make I plus plus. If you check here this condition, so j will be starting at 1 and I is at 0. So if nums of j is not equal to nums of I, no, then j will be moving to 1. Then nums of j is not equal to nums of I, yes, then first we'll be incrementing the I pointer, then putting the variable here. So 1 comes here, so it will be checking, and the j moves here, and if nums of j is equal to nums of I, and I stands here, so we are having 1, so yes, then I moves. Then at next, at 2, it put 2, and the I will be here, and it will be checking once again, it is same, then it leaves, then it will check for 3, it is not equal, then I will be moving front, and I will be keeping here 3, and it will be j, it is same, it don't care, then it will move to j, it is not equal, then I will be moving it here, and it will get 4. So you can return the I value directly, 0, 1, 2, 3, and 4. We'll code this, it is too easy. So we should return I plus 1, because if you check the indexing here, 0 and 1, but the output is 2. So we should return the I plus 1. So int will be taking a variable index as 0, which is the unique elements. So for that I'll be taking unique elements equal to 0. Then we'll be running root. J plus plus. And j will be starting from 1. If nums of j is not equal to nums of unique element, then you can directly move the unique element pointer, the nums of, I will copy this. Equal to Hi Akshnayal, please review my LeetCode. Oh, definitely. Can you share your ID here? Yeah, this is all. Hi Akshay, are you there? We'll be moving to the next question. Given an integer array sorted in non-decreasing order, remove some duplicates and tries such that each unique element appears at most 2 times. Okay. So you need to make sure that there will be 2 elements in the duplicate array. Give me a second.